It's college football Saturday, so we're going to be talking a little trash today. Been waiting to work that one in all week, so hopefully you appreciate that one. I worked hard on it. But my name's Eric Archer. I'm with some great presenters today. I'm going to introduce them to you in just a second. We got a lot of people from a lot of different places, and that's really exciting. Just a couple of housekeeping sorts of things. The chat, it looks like you guys are using that pretty well. You're more than welcome to ask questions in the chat. The presenters will answer most of your questions. If there's something more general about TI or something, I'll try to make sure I answer your question. Got people from all over the place. This is awesome. So very exciting. And it will be a survey. So after the session ends, you guys will receive a survey. Please let us know how it went, what you thought. That feedback helps us, make improvements or modifications to future presentations. And there will be resources in the recording of this presentation available to you on the event website. So you'll be able to get the materials from the presenters themselves and the actual recorded session from Vietnam. Wow, we got people from Vietnam. That's fantastic. That'll be available to you after the presentation. So I'd like to introduce you to modeling garbage and recycling with your presenters, Suzette Herman, T-Cube regional instructor, and Debbie Poss, T-Cube national instructor, both from Georgia. Welcome, ladies. How are y'all?
Doing great. How about you?
Doing great. All right. So the agenda, Suzette, can you tell us a little bit about the agenda, what we're going to be going through in this session?
Yes, we'll start with just a problem statement that you might be able to use in your classroom, and then we will work our way through some pencil paper strategies along with the technology. So lots of different strategies depending on the grade levels that you teach today.
Very cool. And I just want to let everyone in the session know that at the end of this, I'll be picking a lucky winner for some TI technology. So make sure you stick around, and I'll announce the winner right at the end. So, all right. Well, with that, I'm going to go ahead and stop sharing my screen. And ladies, if y'all want to start sharing yours, and then I'm going to turn my video off and take it away.
All right. Well, thank you so much. All right. Well, today we're going to look at modeling garbage and recycling. And as Eric said, I'm Debbie Poss retired from Lasseter High School after teaching 41 years. And
I'm Suzette Herman, and I am recently retired, but I adjunct at Chattahoochee Technical College currently.
And all right, it's here somewhere, I know. There you go. What we're wondering is, where are you from? But you've kind of done that in our chat. Thank you so much. And what do you teach? Because we're just curious as to where you're going to apply this information. So thank y'all for filling the chat with this information. And once again, we're going to go ahead and get started. So basically, finding good topics for modeling is a challenge. But garbage is a problem everywhere. And as we learned from the previous speaker, we really need to look at relevant information. Well, garbage is definitely relevant. So today we're going to investigate the problem of how garbage increases and how cleanup and recycling can help it. Okay. First of all, anytime you are looking at presenting something new, we always think it's good to have a conversation hook. So what I would do is throw a ball of paper at the trash can and say, so how much paper do you really think our school trashes every day?
And then the students might be interested in where their trash actually goes. Is it the school's trash different than household trash? Is there a lot of trash? Is it a problem for your community?
And then you might want to look at some statistics. According to https www.treehugger.com, each American generates daily on average 4.4 pounds of trash. And if you pack that up in cubic feet, it would be the height of the Leaning Tower of Pisa.
That's about 254 million tons. So multiply that by another 2,000. We're hitting billions, guys. That would end up being with individuals putting out 22 billion plastic bottles throughout the year when we total it all up.
Yeah. Kind of dire. What we're going to do is look at a hypothetical problem, and I'll be absolutely honest with you. We're going to make the numbers easy so that we can get through the mathematics. But then at the end, we encourage students to look up the real data and then see if this really is a problem in their area. But here's our hypothetical problem for the day. Anne went to the park one day to find that someone had dumped 100 pounds of garbage. Frustrated, she picked up 20 pounds, but that's really all she had time to get. If each night someone dumps 100 more pounds of garbage, but each day Anne brings one more additional friend and each person picks up 20 pounds of garbage, will they ever be able to clean up the park?
At this point in your classroom, if you presented this problem, I could see this one, Debbie, turning into a 3-act task type scenario. Students may have more questions. They might need more information. So if you don't mind, in the chat, if you can think of other problems that your students might encounter or other questions that they might have, go ahead and include those in the chat.
Okay.
Oh, how large is the park? You know, it's funny
That's a good
because
question.
living in rural North Georgia, there's always a back road where somebody does this kind of thing. It's so frustrating.
Mm-hmm. Okay. Well, we're going to head on. Think about what happens each day in this situation. Okay. Anne went to the park one day to find someone had dumped 100 pounds of garbage. Frustrated, she picked up 20 pounds, but that's all she had time to get. Now, that's what you're given. And I highlighted the information that you probably need to know to the next place. Karen, I hope it's the dump. I don't know. Okay. Next, the next day, someone dumped another 100 pounds of garbage on top of the 80 pounds from the day before. But Anne brought a friend. So by the end of day 2, although there were 180 pounds of garbage in the park, they were able to pick up 40 pounds. So they left 140 pounds for the next day. Now I want you to think about this. They have 180 pounds of garbage. They picked up 40. They left 140. But what happens overnight? Someone is dumping 100 pounds of garbage. So at the end of day 3, or the beginning of day 3, there's now 240 pounds of garbage, but Anne brought 2 friends. So since each friend was able to pick up 20 pounds of garbage, they were able to clean up 60 pounds of garbage. Okay. Now, I want you to think about this. There were 240 pounds. They clean up 60. What does that mean? Yeah. If each night someone continues to dump 100 more pounds of garbage, but Anne continues to bring one additional friend each day, just one more, and each person can clean up 20 pounds of garbage.
Will they catch up? Can the garbage be cleaned up completely? So take a minute now to think about, instead of just thinking about the problem and an answer, think about how your students would think about this problem. What kind of strategies would your students take to solve this problem? So I think that would depend on the age level and the grade levels that you teach. So would they do it numerically? Would they just have a numerical approach and look at it daily? Would they possibly try to organize that into a table? Would they be able to graph the information? Would they be able to discern anything different from the graph or create an equation? Are they more algebraic thinkers to where they want to look at it with a representation, an algebraic representation? Or lastly, do they have sequences in their background? Is this something where they could write the sequence for it?
Well, for the most part, if students didn't have a clue, I would suggest that they try to make a table or a chart to organize the numerical data that they've given. And so we know that on day 1, the trash dump was 100 pounds. So the daily trash to pick up that day had to be 100 pounds. They picked up 20, they left 80. All right. So the next day, the trash dumped was 100. So that means that the daily trash now was 180. Okay. But they were able to pick up, how many people are there? 2. So they're able to pick up 40 pounds, leaving 140. Yeah. Now, so that means that each day, once again, how much is left? 100 is dumped every day, right? And at this point, I think this part of the chart's going to be pretty easy to fill up because you were looking for patterns, and the trash dumped every day is still going to be 100, right? So let's just fill up that part. Okay. Now, the daily trash on day 3 is the total of the trash left at 100. So that's going to be 40. But we've got 3 people on day 3, and they're going to pick up 20 pounds each. So that's 60 pounds. That means they're going to leave 240 minus 60 is 180 pounds of garbage. Okay. And once again, they're going to dump 100 pounds. So the daily trash to be picked up that day is going to be 280. There are going to be 4 people. Each one can pick up 20 pounds of trash. So that's a total of 80 pounds to be picked up. Students can see this logic. They really can. Okay. And so there's going to be 200 pounds left. You're going to add the 200 to the 100 pounds that dropped every day. You're going to have 300 pounds. And now we're going to have 5 people. Each person can pick up 20 pounds. That's going to be a total of picked up garbage. Now let's look at the pattern here seriously. Okay. What is happening? Well, on day N, so to speak, we have N people picking up 20 pounds of garbage. So as a result, we know on day 5, we're going to get 100 pounds, 6, 120, and 7, 140. We can fill up that part of the table too. All right, the trash left on day 5 is 300 minus 100, or 200. So look, there's the same amount of trash left in 2 days. That's interesting. Now, the total amount of trash daily to be picked up on day 6 is 200 plus 100, which is now 300. Well, if we take the daily trash and subtract what was picked up, that means 180 pounds left. 180 plus the 100 gives us 280. And now the daily trash is starting to become less as well. 280 minus 140 is 140. I'm not going to finish this. I'm going to let you finish this and see what you think the answer would be. Are they going to be able to actually clean up the park? Put your answer in the chat. Mm-hmm. Mm-hmm. Okay. Any other suggestions? Well, it is an interesting math problem, isn't it?
And I notice here that Gus says okay, so there's a different answer in days. So are students thinking in terms of when is that going to happen? So we start to see some questions that would be provoked by them at this point.
Mm-hmm. Absolutely. Now,
let's take a look with our graphing calculators and see what we can use to do that with. So I'm going to share my screen now, hopefully. And at this point, we want to take a look at creating a list with our calculator. So I'm using an 84 CE. So I'm going to go into my stat and edit. And then instead of going
Hey, Suzette, we're not seeing your screen.
Share, I'm sorry.
You're good.
Thank you. Thank you.
No problem.
One more click.
Yeah. There it is.
Okay. Thank you.
Perfect. Yep.
So with our normal stat and edit menu, we see our defaulting lists. We're going to actually create our own lists today so that we can give them their own names according to our problem. So we're going to do a second and insert. So that's going to allow us to name our own list instead of using the defaulted lists, because we have several things going on. We want to be real specific with this problem. So we're going to do second and alpha to be able to name the first list the number of days. So we're just going to call it days because we have limited letters. So we're just going to type in using alpha. And instead of having to do alpha in each letter, you can do second and alpha and lock it and then enter. So that gives me a days list. Now, sitting on days, instead of entering data, I'm going to go and actually enter this using a sequence instead of just doing 1 enter, 2 enter, 3 enter, which you can do. But in the event that you want to use the sequence, we're going to go to second and stat, which is list. We're going to move over to calc. Sorry. And under calc, we have, under ops, we're going to have sequence. So I did second list and over to ops, and I'm going to choose number 5 for sequence. So at that point, the nice thing is I don't have to remember the syntax. It's all there for me. My variable is, or my expression is X. My variable is X. I started with day 1, and I believe Debbie's table stopped at 7, so we're not giving anything away. And we're going to step by ones. And when we paste that, we see the sequence syntax there is there for me, and I can press enter and it fills my chart, my table. So I'm going to move up to L1 again, and I'm going to do a second and insert. And we want to look, I'm only going to put in one of the lists for the trash that's left, because that's what we're trying to decide is when or is the trash going to get to 0? Am I eventually going to pick it up? So again, I'm going to name it, doing second and alpha to lock the letters. I'm going to do L trash for left trash, the trash that's left. So that just kind of reminds me of what my table represents. So typing those letters in, we all know that that's a little tedious sometimes to find the letters because we're not getting the QWERTY keyboard here. But when we put that in, we can then enter the values. The first day, after the first day, there was 80, oops. There was 80 pounds left. So then we had 140 pounds left the second day. The third day, according to Debbie's calculations, was 180, then 200. And then we reached 200 again on the 5th day. And then we started to see a little bit of a decrease. So we start to see some patterns there. So at this point, the students could continue that recursive process and get to a stage where they could tell if the trash remaining was going to reach 0. And I think we see the patterns, but would they approach it graphically? Would they want to take a look at the graph? So while we're here and we have our table up, let's go to our stat plot and take a look at this data. So we're going to go to second and y equals, and we're going to turn the first plot on. And just looking at a scatter plot, the first type, we also realize that, hey, wait a minute, our data is not in L1. So we're going to go to second and list, and there's where my names are of the list that I just created. So I'm going to let my X values come from my days. My independent variable would be days then, and my Y list going to second and stat again. I want to choose number 8 in my list there. And moving down, I can mark those with whichever object I choose. I tend to choose the plus symbol just because it's easier, it's smaller, but not so small that I don't see it. Now, you also notice on the color edition here, you have the option to make it any color you want. I believe it defaults first to blue, but I'm choosing red just to stay consistent with our presentation as we go. And then next, we would take a look at our window. So with our data, we know that we started at day 0. So we want to look at all of the data that we have, up to 10 days maybe. Our table only went to 7, but I always like to go past where I've put data in. So YMN, we would start at 0, and without really thinking too much about it, we saw a 200, but let's go a little bit more than that. So let's look at 500, and we definitely wouldn't want our calculator to count by ones there. So let's count by 50s. And then take a look at our graph, and I see a line there, which means I had an equation in. So let's clear that out and relook at the graph. So we start to see some patterns here. Not only did the data look like it was pattern, we see that now maybe we could give a name to this. What type of data are we looking at? So at this point, maybe we want to look at some of the other scenarios. So I will move to the presentation, and looking at the table there, we see that Debbie included other columns or other rows here than what we included in our list. So we've looked at the graph of that one. So Debbie, you want to pick us up here with your other lists?
Absolutely. I went ahead and typed them all in, being the basic overachiever that I am sometimes. And because I wanted to see what the relationship was actually between the daily trash and the pickup trash and the leftover trash. And if you look at the graphs of the daily trash and the pickup trash, and I put both of those in a graph for the next page. There it is. Yeah. Okay. You see the black points, and by the way, I use squares because I'm old. At any rate, the black squares are basically how much garbage is picked up each day, but the blue squares are how much you started with each day. And I thought this was fascinating because basically what we have left over each day is the initial trash minus how much was picked up. And so if you want to look at this graphical subtraction, then look at the height of the, I don't know if you can tell this, but at any rate, the blue graph minus the black graph gives you the points on the red graph. And so you can actually see that the trash is being not only picked up, but it's becoming less every day. It's decreasing, especially on days, okay, what is that? 1, 2, 3, 4, 5. And out days 4 and 5, it starts to be the same thing, and it starts to decrease. And yeah, absolutely, guys. It looks to me like linear and quadratic functions. It totally does. Okay. Now, can we write those functions? Well, here's the pattern. We've got the initial trash and the trash picked up and the trash left. So look for patterns. What's happening with the initial trash? What kind of function is it? It looked to me like it was totally quadratic, but once again, let's see if one would fit it. I don't know. What about the picked up trash? What's happening there? I think that constant rate of change is just screaming, oh yeah, I'm linear, okay? And then the total trash left, well, what would happen if you have a quadratic minus a linear? I think it should be quadratic. So, but those are some neat applications or neat things to discuss with students. You know, if you've got something with squares and you subtract something with linears, think about basically combining like terms. Yeah, it kind of ought to be square. So, at any rate, it is.
So can we write the equations for these? So if we go back to where we were in our stats, I will share my calculator again. Okay, so you see my graph on the screen still. I'm going to quit and I'm going to go to stat. And this time, instead of looking at the data, I want to see if I can get that equation. So we're all kind of familiar with the regression equation. So we've decided that this should be quadratic. But we realized that, wait a minute, we didn't put our data in L1 and L2. So let's go back and find those. So we would go to list and choose our days for our X list. And then we would go back to second and stat, which is our list, and pick up left trash for our Y list. Now, we didn't have any kind of frequencies here, but we can store our equation into Y1 or Y2 into our functions so that we can take a look at that equation and then also look at the graph of it as the function. So to store that, remember that a quick way to get to your Y1 is to do alpha and trace. So if you haven't noticed those buttons, alpha y equals is your fractions, and you can right arrow over to get to the different menus, or you can go directly to alpha and trace. And I'm going to choose Y1 to store my regression equation. So when I calculate here, oh, nice numbers. My A value for this quadratic is -10. My B value is 90. Now, would my students recognize the fact that A should be a negative? Should they recognize that A should be negative? So once I've done that, I'm going to go to Y equals here, and I'm going to look and see, there's my equation. And then notice that we have a nice graph of that. Now I'm going to turn that one off for just a second because I want to look at another feature. So if I press enter on the equals, that's going to turn my function off. But I want to go to stat. I'm going to quit and I'm going to go to stat again. And I'm going to look at a different feature for the regression. If I'm not really sure, and it's a little more unusual than this one, and I'm looking for the patterns, I can go to, instead of scrolling down, I can scroll up to get to the bottom. And I want to take a look at the quick plot and fit equation. So I'm going to choose that one. And you'll notice you get a cursor on your screen. This cursor is going to allow you to choose some of your points that you have chosen or that you've included in your list, in your stat plot. So I'm going to go as close as I can, and you'll see at the bottom, you see the coordinates. We know that we want to get close to 2, and I believe that was 140. So that's pretty close. So I'm going to choose, I'm going to press enter, and then notice that that point is now selected. And I'm going to choose another couple of points to kind of get an idea for the data. And I'm going to move around on that one just a little bit to see where I can get closest. And using a few more of those, I'd like to include more than I need just to give it maybe a better fit, especially for things that are a little more unusual. This one's pretty patterned. So maybe here. And then I'm going to go to the other side just for one more point.
But this is another good time to talk to students about how many points do you really need to be able to determine if it's a quadratic or not, or to get a good fit for a quadratic, I should say.
Okay, and you'll notice here, well, you know, we always, when it was linear, we wanted 3 instead of just 2 because we We just were that way. We had to make sure. But you'll notice here on my screen, the fit EQ is a menu item. In the bottom right corner of my screen, the fit EQ has to be controlled with the graph button. So when I choose fit EQ, then I get those regression models again. And if we look down the list, we think that it's quadratic. So that looks like number 3. So I'm going to choose it. And notice that my equation is on my screen. So I have some decimal values that I didn't have earlier. So not quite as clean, but a very close graph to the data that we have. So notice there that we have another menu option that says we can store it. So let's do that. And we look. The X lists, we didn't really have to change here, but we can store it. And we had things in Y1. So let's tell it okay. Or Y2. So if we go to our Y equals screen, we can turn that first one back on. We have both equations now where we can look at the differences in them, and we see very slight. But it's neat that you can still see the blue underneath with the red. Slightly different, but very good representations in both cases. But both of those are ways that you can use the technology for your regression equations. And then Debbie has a couple of others to share with us. So I will stop sharing and allow her to take over.
I was going to suggest that the last one is excellent when you have a lot of data points and you just want students to be able to pick up certain ones. And I'm looking for share. Just give me a moment. I do know where it is, I promise. Okay, there it is. Okay. Now, I've always been in love with the transformation app. So I'm going to look at the transformation app. For those people that aren't familiar with it, the app, press the apps button and then move up. The transformation app allows you to, there we go. Now I can see my enter. Okay. Transformation app allows you to have 4 different variables, A, B, C, and D, and then allows you to move or change those variables so that students can fit curves to their, well, to whatever they want to fit, to be honest with you. Now, the app says press any key, so I'm just going to press enter. And when you look at your Y equals right now, you'll notice that these first 2 look more like recording than they did earlier. And that's because the transformation app is on. The first thing I'm going to do is turn my stat plot on, because earlier I had the daily trash, the leftover trash, and the pickup trash. Now, Suzette just looked at the leftover trash, so I'm going to do the same thing. And look at our graph of the, did I not hit turn on? I didn't. Okay, let's try that once more with feeling. Okay, turn on this time. Thank you. There we've got that one. Since I've got the transformation app on, I can use A, B, C, and if I needed to, D, to be able to fit an equation. But the neat thing about the new transformation app is if I back up over the animation symbol and hit enter, I got a lot of more things to play with. For example, I can change the color. That's nice. I could look at different transformations, but Y1, this is interesting to me. You see, they've already designed a couple of different equations that I can play with. For example, I can change A and B in a line and see what happens. I could change A and B and AX squared plus B to see what happens. I could look at a quadratic in vertex form, or look at one in factored form, and that's the one I'm going to look at, but I'm going to show the rest of them to you. Also look at quadratic in standard form, and these are already, yes, you can get the recorded video, okay? And these are already built in. I don't even have to type them. Here's one in cubic, another cubic, absolute value, sines, cosines, and tangents. So all of these are built-in functions that they thought you might be interested in working with. And this is the one I'm going to look at. Okay. Because I know already, so I'm going to hit OK. So move my cursor down to OK and hit enter. And so now the next thing I'm going to do is find out what my variables of A, B, and C are already. Now, if I look at the window, you'll notice that I have the same window as Suzette. If I look at the settings, though, I may have different values. Okay. My A, I think, should actually be -1. Okay. My B, I don't know. I'm going to hit 0. And my C should be 0. Now, if I look at graph, I don't see a thing. But I think that's because I have one root at 0, but I'm pretty sure the other root is bigger than 0. So I'm going to move B down to 0 and then move the cursor over to increase it until I think I'm seeing my graph. And at this point, I think maybe it should be a more concave curve than just with a -1 coefficient. It's going to move this up to -1. And now I think I need to go backward instead of forward, because if I went forward, it's going to give me, yeah, a positive value. So I don't think that's going to work. So let's move backward until I get a curve that looks like it might fit. And I don't know. How's that looking? Not quite, is it? So maybe what should happen? Should perhaps B be different? Let's move back down to B and increase it a little bit. Oh, crazy. Okay, so move back up to up. Now, why do I do this? Because I want my students to get a number sense, to get a sense of what's happening to the graph as they change the variables. And they can tell right now that was a huge jump. So we need to then decrease that. And sooner or later, they're going to get the perfect fit for this. And the reason I like working with this one in factored form is we really wanted to see when this graph would equal 0, because that represents the amount of trash picked up. And this tells me that at 9, which would be my factored form x minus 9, at 9, then my actual trash picked up should be 0. So I like that. I just think that's kind of neat to be able to give students the power to fit an equation to a curve.
Seeing each of those parameters in those different formats, as y'all noticed, every one of those function types had those parameters available. So that really gives the students a lot of ability to watch those parameters effects on each of the types of graphs.
It definitely does. All right. Now, before we go any further,
John, you were saying you haven't seen this feature before. Do you have any questions? Okay.
no? Okay. All right. Now we use the regression equation capability and the quick plot and fit and the transformation app. The next thing I want to do is sequences. Okay.
One
But before we
more thing on
do,
that one, Debbie, before you move on to
yes.
sequences.
Uh-huh.
Another thing to remember, guys, is when you go into that transformation app, you turn it on and it doesn't turn off until you go back in and turn it off. So that's another thing, that when you have used it and you go back and do things with your calculator, if it doesn't look the same, remember to turn it off.
That is a good point. In fact, I think I'll go ahead and do that right now. Although I really don't have to for my next sequence, I'm going to go ahead and turn the app off. That is an excellent idea. Thank you for reminding me to do that. And it's just easy to just quit the transformation app. Okay. Thanks. Now, let's
Then
go
your
back
y
to
equals
this.
will look normal.
Yes. Okay. We're going to use the transformation app, and we're also going to look then at sequences. Do students know summation formula? That's another good question. So far, what we've looked at is to see how well my equations fit the data. And you could tell that it did. Another way to check this, though, was to actually look at our list, and we could edit list, move over to, oops, I didn't clear that out. There you go. We can go over to list 1 now and say, did our equation actually model our list? My equation was in list 1. So what I can do at this point is actually highlight list 1 and go to, all right, where'd my mouse go? All right, second trace, just like, no, alpha trace, just like Suzette did earlier. And I'd like to find Y1 at all the values of my days. So I'm now going to go to list, second list, and then find day and close that. Hit enter. And you'll notice that this is another way to verify that we have an equation that models our leftover trash. All right. Now,
What you just did is a feature that I've used a lot since I learned it, but evaluating your Y1 at specific values. So your students are not having to calculate those. You can actually get your table to create by using that Y1 and L1. So it's literally pulling every day value 1, 2, 3, 4, 5, 6, 7 into that function that you had in Y1.
Thank
So
you. You're absolutely right.
that's a good time saver. And it actually helps with the troubleshooting in class when people aren't typing things in correctly. So they miss a number or something didn't happen. And then you also end up with those dim mismatch errors. So that's a good way to avoid some of those mistakes.
Yes, it is. I agree. Now, we kind of led you into looking at one table. However, whenever we've done this, students have also done this another way. And let's look at a different way students might actually solve this problem. All right, suppose they're looking at total trash deposited and total trash picked up and total trash left. First of all, why don't we look for our patterns? Look at the total trash deposited. What really is happening? After day 1, there is 100 pounds of trash that was deposited. But how many pounds were totally deposited after day 2? 200. On day 3, there were a total of 300 pounds of trash that had been deposited, and then 400, 500, 600, 700. That's an easy pattern to see. What kind of function is it? I'm looking at a constant rate of change there. I think it's pretty linear. Now let's look at the total trash picked up. What's happening here? Well, on day 1, we actually pick up 20 pounds of trash. But on day 2, we have picked up 20 pounds of trash on day 1, but we have 2 people now picking up trash. They each pick up 40 pounds. So now we have a total of 60 pounds of trash picked up. Now on day 3, they've already picked up 60 pounds. We've got 3 people picking up trash. They pick up 60 pounds. So we've now picked up a total of 120 pounds. On day 4, we have that 120 plus 4 times 20 is 80, 200. On day 5, we have 200 plus 5 people picking up 200 pounds or 20 pounds of trash each. So that's 300. On day 6, we've got that 300 pounds plus 6 people that pick up 20 pounds of trash each. So that 300 plus 120 is 420. And then on day 7, we've got the previous day's 420 plus 7 people picking up garbage at 20 pounds a day, which is 140 for a total of 560. Now, what type of function is this? That's a good question. If students are looking at, successive differences, they're going to see that we've got a 20 and then added 40 and then added 60 and added 80, added 100, added 120, and added 140. This appears to be a quadratic function, that's right. But let's see. The trash left is going to be 100 minus 20, which is 80. Then 200 minus 60, which is 140. 300 minus 120, which is 180. 400 minus 200, which is 200, 500 minus 300, which is 200. We're getting the same amount of trash left that we did earlier. So this is just another way to look at our function, or our problem, I should say. And what kind of function is this? Well, we thought earlier it was quadratic. Well, if trash grows linearly and trash pickup grows quadratically, will we always be able to clean up trash? Well, as George Polya says, let them learn guessing, let them learn proving. I will let that be for the reader to determine. But let's look at the sequence mode, because this is the last thing we want to do. Okay. That means we're going to bring up our calculator and change the mode to sequence. I don't know how many of you have used this before. It's a neat function option. All right. Now, basically, sequences allow us to use either recursive or explicit forms. Remember that my use of n, the first thing in my table was the idea of picking up garbage. So basically, I'm going to do this recursively. So I started with 100 pounds of garbage. I moved this down to 100. And then I move it back up again and realize that every time I would take the previous day, which is the use of n minus 1, and add the next day. Add 100, right? So let's see. I need to find u. Do you see u on your calculator somewhere? I think it's above the 7, but it's in blue. Oops, I hit 7 twice. So anyway, I had to hit second 7 to get the u. And then I'm going to put parentheses. When I hit the X button, it looks like an N now because the calculator knows what mode I'm in. N minus 1 plus 100. Now, just to make sure I've got this right, let me look at the table and see what it looks like. Table, that's table. Thank you. Okay. And you'll notice that's exactly what's happening. I had 0, gave me an error because I didn't look at time 0. But every other time it's giving me that total amount of trash picked up each day. Now I'm going to go back. And for the next one, we're going to look at the, all right, at this point, I'm going to have to stop for a second. And this is where I was wondering where it was. My bad. Okay. Nope. Back up one. All right, we're going to use recursive method again. And so for V sub n, now remember this is the amount of trash picked up. The first day I started with 20. And each day I'm going to take the 20, well, the term before it. So let's see, I'm going to look for a V this time, and that's going to be second 8. So that's V sub n minus 1. And I'm going to add, well, what am I adding each day? I'm adding a linear sequence, and each day n people pick up 20 pounds of trash, so I'm adding 20 n. Now, does that make sense? I'm taking the previous day, and I'm adding 20 times n. Let's see if that makes sense when we look at our table. Yeah, it does. So the first day I picked up 20 and then 60 because that's 20 plus 40 and then 60 plus 60. So that's ending up just the way we think it ought to also. Now let's look at the third one. And this one's much easier because our third sequence was basically just how much trash there was minus how much was picked up. So this is equal to U sub n minus V sub n. And if we look at our graph this time, you'll notice that we've got the orange graph, or the gold graph, is how much trash was deposited every day. The green graph, and you can see it curving upward, is how much trash we pick up every day. And that difference is the red graph, which is the total trash picked up. So are there any questions about that? How we use the sequence mode. I like sequence mode. I think that's neat. All right. Next, and remember, this is what we did. We changed the mode to sequence. We typed in our equations, and that's what the data looked like. Remember that I still had the scatter plot on, so that's why I had darker red points. Now, how can we find the equations without having to depend on the calculator? That's another question. Do they know how to find the sum of terms of sequences? Well, remember this table. Look at the 20, 40, 60, 80, 100, etc. And once again, we looked at this and decided that these were successive differences. And if the sequence is a sum of successive differences, if the successive differences are linear, then basically what we're looking at is a sequence of partial sums. But we need to be able to add the terms of an arithmetic sequence. Whenever I have to add the terms of an arithmetic sequence, I use a tape measure. And I just fold it over because you have 1, well, actually you have 0 plus 60, and then you have 1 plus 59. You have 2 plus 58, 3 plus 57, and students see that this total is going to be 60. But instead of having 61 numbers, because remember I started with 0, I now have half that many because the tape measure is folded in half. And so the way I teach finding the sum of an arithmetic sequence is you add the first term plus the last term times the number of terms divided by 2. And students seem to remember that. There are a lot of other ways to remember that too, but I like the tape measure. It's a good visual. So the total daily trash deposited, the use of bin was 100 N. I think we all agreed on that one, that was a nice linear model. But the daily trash picked up is 20 N. So that means that the total trash picked up, that V sub N, rather than having to write it recursively, could be written as 20, our first term, our first number of days, the first amount of trash we picked up, plus 20 N, which is the amount of trash we pick up on day N. That's first term plus last term, times the number of terms, which is N divided by 2, which is, by the way, 10N plus 10N squared. The trash left is W sub N, which was U sub N minus V sub N, which was our 100N minus this 10N plus 10N squared, which is negative 10N squared plus 90N, which is the same thing that we got doing it the other 4 different ways. So this is a task that has a very low entry, but a very high extension point. So are there any questions? Do we have some good comments?
We do. Karen just mentioned that this could be a good flipped lesson. You could use this video and allow your students to go through the video to learn some things on their own if they have the graphing calculators.
And this is true, yes. Well, there are extensions to this, needless to say. And so some extensions are, so what if somebody was dumping 200 pounds of garbage each day instead of 100? Will the group be able to clean up the park? How long will it take? Or what if someone dumped 500 pounds of garbage a day instead of 100 pounds? Look at this in functional notation and explain what's happening here. And then you could follow up with students' projects. They research it and find data about a particular garbage problem they find interesting. And keep in mind that we assumed a constant amount of garbage each day, whereas that's not totally realistic. If you smooth the data, and you might have, for example, a fine for dumping too much garbage, that might not be too far from the truth. Okay? But there are a whole lot of things that a student could do now to create a similar model. Another extension is, what if they start with 100 pounds of garbage, but instead of dumping the same amount, they dump 10% more each day? Will they ever be able to clean up the park? How many days will it take? Or perhaps only 5% more garbage. Look at this one once again as functional models and see what happens. All right. Suzette actually did this with students. And
yes, and this was really not it was a fairly low level ninth grade group. So it was interesting that they all kind of took the same approach with the tabular or numerical, but their organization was completely different. I mean, even though they have basically the same information, if you'll flip to the next slide, Debbie, you'll see a couple of other examples. They were getting the same results, but even their way of organizing themselves were completely different. So at this point, they didn't have a lot of the functional background. So their approach was the numerical or tabular approach, but they were still reaching the correct conclusions. So I think the interesting thing with this particular problem, as Debbie and I were going through different strategies, is the fact that you can use it through many age ranges, through many different ability groups. And again, mine was not an honors level group by any means. So it was interesting to see that they actually took on the problem and were challenged and were engaged in getting a solution. So
thank you very much. And thank you, Eric, for hosting this. Are there anything else? Is there anything else we need to do to wrap it up?
Karen gave one good extension also, that what if if each of the friends brought a friend instead of just the individual bringing another friend each day. So that was another good extension that she mentioned earlier.
That's a great idea. I like this.
Well, I like the comment that just came through. It says, never thought garbage becoming so engaging. Yeah,
Exactly.
Yeah, all this trash talk's actually really useful.
Well, and there's good media. There's good things that you can find in the media right now as well, with the with the Pacific and the things that are happening with all the trash being dumped.
Oh, for sure. Yeah, absolutely.
It's definitely a relevant problem for all of us.
Yeah, unfortunately, that is true. I think hopefully that gets better with more and more education. Sessions like these, because you're bringing this to teachers who are also going to bring it to their classrooms, make their students aware. And I think that the awareness is a big deal, not just the mathematics behind it, but just awareness in general of, hey, make sure you're not throwing trash in the park. It's important. So. Well, Debbie and Suzette, great job. Fantastic. Yeah, got some nice comments in the chat. Thank you all so much. And we are at the end of the session. I just want to remind everyone that we all of this information will be available to you on the event website after everything's done. The next round of sessions are going to start in about what time is it now? We're going to start in about 17 minutes, so make sure you're ready for your next one. And we do have a winner. So thank you, everybody, for hanging with us and engaging in the chat. And so that was awesome. The lucky winner is Phyllis Cipriani. So congratulations, Phyllis. We'll reach out to you and make sure the technology is sent your way. We'll ship it to you, and you should hear from a TI representative in the next couple of days. So thanks, everybody. Congratulations, Phyllis, and thanks, Debbie and Suzette.
Thank you.
Thank you, guys.
Bye-bye.
Back into practice mode. Yeah.